Hey guys, my name's Dallin Briggs, and I'm a mechanical engineering student here at Brigham Young University. And normally I spend my time making and developing software and hardware for unmanned aerial vehicles, or UAVs. But today I've come up with a 3D touchless interface controller for the SeaPerch robot, which allows you to control the SeaPerch robot just simply by the movement of your hand. And it's going to track the position of your hand, and I'm going to show you exactly how that's done and why it works. Okay, so this is the actual 3D touchless controller itself, and essentially it's just half a box with aluminum foil on the inside of it, and an Arduino microcontroller and a motor for demonstration purposes. And so what this is doing is these three plates here represent your coordinate planes, like in a Cartesian coordinate system. So this would be the XY plane, this is the XZ plane, and this is the YZ plane. And by measuring the distance my hand is from each plate using capacitive sensing, I can figure out the position of my hand in a 3D space in this area right here. Now, I don't actually have a SeaPerch robot, but this motor over here can represent one of the three motors that is on the SeaPerch. And there are different motions to control the robot. For example, so when my hand is in the center of the cube here, the robot won't be doing anything, it'll just be sitting there. But if I want the robot to just go straight down, I lower my hand. If I want the robot to go up, I raise my hand. If I wanted to turn right, move it to the right, left, forward, back, and so forth. And to show that this is working, I have this Adafruit motor controller, and you'll actually see it move as I move my hand. So right now, when I bring my hand all the way down, it's calibrating for the first time. And now when my hand is in the middle, it might have a little bit of noise, but it should be not moving at all. Now if I want the robot to go down, I move my hand down, and that would be the down motor, and obviously send it down. But if I want the robot to go up, then I move my hand up, and the motor moves in the reverse direction. And that is essentially how this is going to work for the SeaPerch robot. Now, to understand how capacitive sensing works, we have to understand a little bit about how capacitors work and what they are. So, the basics of a capacitor is they're essentially two electrically charged plates that are separated by some kind of insulating material. Now, each capacitor is given a capacitance rating, and that capacitance rating is a function of the distance between each of the plates. And so if we change the distance between each plate, like if we make the distance smaller, the capacitance will actually increase, but if we increase that distance between each plate, the capacitance will decrease. Now this is important because to measure the distance between each plate, we can see how long it takes the capacitor to change voltage. Now, when you give a capacitor a change in voltage, it doesn't instantly change to that voltage. It takes a little bit of time for it to reach that new state or that new voltage. And that time delay is given, it's a function of a time constant, which is given by tau is equal to RC, where R is the resistance of the circuit and C is the capacitance of the capacitor. So there's a time delay that's being changed, depending on, because C is part of that time delay. It's a time delay that's being changed by by the distance that's separating the two plates. Now, how our system over here is working is that our capacitor is just two plates, just like every other capacitor, but one plate is being represented by each of these faces, and the other plate is being represented by your hand. So if I want to measure the distance of my hand, that is to the plate, I can measure how long it takes a changed voltage to come back to the Arduino. So the Arduino is actually sending a signal to each of the plates, and that signal is alternating the voltage on each plate, and that that alternate state is then coming back to the Arduino and reporting how long, and the Arduino is taking taking a measurement of how long it took that change state to return. Now, so if I move my hand closer to the plate, it's going to take that alternated state longer to come back to the Arduino. And because it takes longer, the Arduino is able to see that and say, okay, now your hand is a little bit closer to the plate. But as my hand is further away from the plate, that alternated state that's coming back to the Arduino is coming back much faster. And so that's how we're able to estimate how far away my hand is to each of the plates. Okay, so step one is to construct the cube. And so cut out 3 pieces of 12 by 12 inch cardboard, just like that, square cardboard, and just a little bit smaller aluminum foil. And you can either do this with tape or spray glue. Spray glue works pretty good, but you're just going to spray some of this glue on there. And you're going to take this aluminum foil and smash it down so it's nice and flat against that cardboard. And then you're going to you're going to do this 3 times for three plates, and then you're just going to tape those 3 plates into the shape of a half cube. These are what the 3 plates should look like taped together. Make sure that none of the aluminum foil on the individual plates are touching each other. You can check this using a multimeter and seeing if you have any kind of connectivity across the 3 plates. Now this is the part where you actually have to solder all the wires together and connect the Arduino to the half cube of plates that we just made. Now I'm not going to show you how to solder because that'd be a whole nother video, and there's lots of great YouTube tutorials on how to solder and what the best way is, but I'll explain this diagram. The positive 5 volt is the 5 volt pin on the Arduino Uno. Pins 9, 10, and 11 are just pins 9, 10, and 11 on the Arduino. Those 10K symbols are 10,000 ohm resistors, and the 270K symbols are 270,000 ohm resistors. Now notice how the 5 volt line is also connected to a portion that looks like it's not touching the wires going from the pins 9, 10, and 11 to the bottom, front, and side plates. That's because the 5 volt line is also soldered to the shielding of the wire. And this is to reduce the amount of interference that you'll get and produce a much more reliable signal. This is an example of how you can solder together all the resistors. Once you have your wiring harness made, just take the alligator clips and clip them to each individual plate. I usually clip them down by the edges. The next thing is to connect all the motors to ports M2, M3, and M4 of the Adafruit motor shield. Then you'll want to connect all the pins shown in the diagram to the Arduino through the motor shield as well. Once everything is connected properly, then you'll want to load the Arduino program that is found in the description below. Once the program is running, you can monitor if it's working or not by monitoring the serial port found in the Arduino IDE. You should see the values change as your hand moves across the plates. This concludes my tutorial. If you have any questions, please leave them in the comments section below the video and I'll do my best to answer them. Thank you.